Assalamu alaikum. My name is Azmat Hussain, and today I'm gonna teach you Newton laws of motion, in which we will discuss law of inertia, that is also called the first law of motion, and also called law of inertia, the second law of inertia, the second law of motion, and also the third law of motion, that is action and reaction forces. So let's go forward. As we all know, while most people know what Newton law says, many people do not know what they mean or simply do not believe that what they mean. So here is the definition of here are some definitions of Newton laws of motion. So first is the first law of motion. So an object at rest will stay at rest, and an object in motion will stay in motion at constant velocity unless acted upon by an unbalanced force. The definition of second law of motion: the product of mass and acceleration is equal to the applied force. And the third law of motion: for every action there is an equal and opposite reaction. These were the three laws of motion which was explained by the Sir Isaac Newton. So first of all, the first law of motion, that is also the law of inertia. So an object at rest will stay at rest, and an object in motion will stay in motion at constant velocity unless acted upon by an unbalanced force. For example, हमारे पास एक ये मैं एक एग्जांपल लेता हूं जिसमें हम ये कहते हैं कि फॉर एग्जांपल हमारे पास ये एक बॉक्स है. ये बॉक्स अगर ये किसी जगह पे हमने छोड़ दिया है, ये क्या रहेगा, ये always it will be at rest, and जब तक हम इसके ऊपर कोई एक्सटर्नल फोर्स अप्लाई नहीं कर रहे तब तक ये क्या करेगा, ये रेस्ट में ही रहेगा. और इसकी मोशन को, इसकी स्टेट को चेंज करने के लिए वी रिक्वायर्ड व्हाट, वी बेसिकली रिक्वायर्ड द फोर्स. और ऑल्सो इसकी बेसिकली स्टेट को मेंटेन कौन क्या करता है, दैट इज इनर्शिया. मतलब अगर ये स्टेट ऑफ रेस्ट में है, ये स्टेट ऑफ रेस्ट में इसकी स्टेट को मेंटेन क्या करता है, दैट इज इनर्शिया. और अगर ये मोशन में है तो इसकी मोशन को मेंटेन क्या करता है, दैट इज आल्सो इनर्शिया. सो दैट्स व्हाई an object at rest will stay at rest, and an object in motion will stay in motion at constant velocity unless acted upon by an unbalanced force. So one minute. So first law, inertia is the tendency of an object to resist change in its velocity, whether in motion or motionless. As we can see, here is the here we have pumpkins. So these pumpkins will not move unless acted on by an unbalanced force. So this is basically what the inertia maintains its this state of rest. So here you can see an animated video. So what is first law? So once airborne unless acted on by an unbalanced force, so gravity and air fluid refraction, it would never stop. अगर इस बॉल को, अगर दो चीजें ना हो, मीन्स कि इसको फ्रिक्शनल फोर्स ना हो और ग्रेविटी ना हो, तो ये बॉल जिस तरीके से किसी ने इसके ऊपर फोर्स लगाई है, तो ये फॉर द लॉन्ग टाइम ये क्या है, ये हमेशा के लिए इट विल ऑलवेज मूव इन द स्ट्रेट डायरेक्शन, जिस डायरेक्शन में इसके ऊपर फोर्स अप्लाई हुई होगी. Then you can see also the first law, unless acted upon by an unbalanced force. So this golf ball would sit on the tee forever. वाई। सो इसकी इस स्टेट को भी मेंटेन करने के लिए इनर्शिया क्या कह रहा है कि मतलब दो फोर्सेस ऐसी हैं जो कि अनबैलेंस्ड हैं, दैट इज ग्रेविटेशनल फोर्स इज एक्टिंग अपॉन बाय दिस, ऑल्सो द एयर फ्रिक्शनल फोर्सेस. So why then we do observe everyday objects in motion slowing down, becoming motionless seemingly without an outside force? तो ये ऐसी कौन सी फोर्स है जिसको हम देखते हैं कि मतलब बिल्कुल आहिस्ता होती जाती हैं चीजें. फॉर एग्जांपल अगर आप न्यूट्रल गियर में किसी गाड़ी को चला रहे हैं तो वो एक टाइम आएगा वो रुक जाएगी. वो ऐसी कौन सी फोर्स की वजह से रुक जाती है? सो इट्स अ फोर्स वी समटाइम्स कैन नॉट सी, दैट इज कॉल्ड फ्रिक्शन. So objects on Earth, unlike the frictionless space the moon travels through, are under the influence of friction. So objects on Earth, unlike the frictionless space the moon travels through, are under the influence of friction. So what is friction? What is the unbalanced force that acts on an object in motion? That is friction. So there are basically four main types of friction. One is the sliding frictions like ice skating. The second one is rolling friction, that is bowling, and fluid friction, that is air or liquid, that is by air or liquid, and air or water resistance. So the fourth one is static friction, that is initial friction when moving in an object. Here we have an example like आप लोगों ने भी इसको फील किया होगा. So let's slide a book across a table and watch it slide to rest position. The book comes to a rest because of the presence of force, that force being the force of friction which brings the book to a rest position. For example मेरे पास एक यहाँ पे टेबल है, मैं क्या कर रहा हूँ कि ये मेरे पास टेबल है और इसके ऊपर ये एक बुक पड़ी हुई है और मैं इस बुक को क्या कर रहा हूँ कि मैं इसके ऊपर फोर्स अप्लाई कर रहा हूँ. तो इसके ऊपर मैं जब फोर्स अप्लाई करूंगा तो मुझे फील होगा कि this book requires more force to move faster, or this book requires less force to move slower. So what force will oppose this motion of the book? There will be the frictional force between the table surface and the surface of the book. So that force basically resists the motion of book. So another one is, in the absence of a force of friction, the book would continue in motion with the same speed and directions forever, or at least to the end of the tabletop. So Newton's law, first law, and you, for example, here you people can see a driver is coming with in a fast car, and when car hits the wall and driver gets escape into the front of in the front direction of the car. Why? ये पीछे क्यों नहीं गया? So don't let this be you. Wear seat belts also. So because of inertia, because including you resist changes in their motion. If the car is in motion, you are also in the motion. So what inertia wants? Inertia wants this motion should be continue. But when you hit the wall, when the car going 80 km per hour is stopped by the brick wall, your body keeps moving at 80 meter per hour. So now the question is arise, where does this force comes from? So this question is for you. Basically these are the pseudo forces. Pseudo forces, these are unknown forces. We don't know where these forces are coming, and you people can Google these pseudo forces. Now let's go towards the second law of motion. Here you people can see the ball is moving to the left and right. For an example, the Newton's second law of motion is that for example, this is what is not writing. F is equal to ma. The product of mass and acceleration is equal to the applied force. For an example, what is basically the thing? Here is a box. I am applying some force on this box. If apply some force on this box has also some mass, and by applying some force on box, this box will move in the direction of applied force. So in Newton's second law, the net force of an object is equal to the product of its mass and acceleration. The net force. What will be the net force? Net force will be equal to the product of its mass and acceleration. Product of its mass of object, and the acceleration with object is moving. Acceleration. So when mass is in kilograms and acceleration is in meter per second square, the unit of force is in Newton. Okay. So what is the basically the Newton F is equal to ma. Okay. So how this force will be in Newton? For an example, as we know, uh, in Newton's second law of motion. For an example that I have, uh, for an example, acceleration is directly proportional to the force. As much as bigger I applied the force, the object will move, will accelerate as much as more. And again, according to the Newton's second law of motion, acceleration is inversely proportional to the mass. If an object have larger mass, the object acceleration will be less because it is inversely proportional to the acceleration. So when we combine these two, because the left hand side of the equation of the expression is same, so we can write like this: a is directly proportional to the force and inversely proportional to the m. So let me remove this sign of proportionality, so keep the sign of equal, so place a constant, that is k into f divided by m. So according to the Newton's second law of motion, the value of k is equal to 1, so the a will be equal to f by m. So here we can write like this: ma is equal to f, or f is equal to ma. So the 1 Newton force will be like when this 1 Newton force is equal to the force required to accelerate 1 kilogram of mass at 1 meter per second square. That is, 1 Newton force will be equal to the force required to accelerate 1 kilogram of mass. 1 kilogram of mass at 1 meter per second square acceleration. This is the SI unit of now the Newton's second law of motion, that is F is equal to ma. How much force is needed to accelerate a 1400 kilogram car 2 meters per second? So First of all, write the formula, that is F is equal to ma. Fill in the given numbers and units. So what is the mass of an object? Like 1400 kilogram multiplied by acceleration 2 meters per second square. So 2 meter per second square. So solve for the unknown values. So it will be equal to 2800 kilometer per second square, kilogram meter per second square. So you also can write it 2800 Newton. Here you can see, you can test yourself net force, that is in Newton. So 10 Newton force, mass is 2 kilogram, acceleration is 5 meter per second square. I have solved some of questions and answers are like this. So from here you can solve this one as well. And because these two are first was solved, so here you have to solve the mass in kilograms, and in this section you have to find the acceleration, and in this section you have to find the net force. So here is the formula, like F is equal to ma. When you require anything like in this section, you require mass. So here acceleration is multiplying with it. So if this one is multiplying in the right hand side, so it will be get divided with the left hand side. So mass will be equal to force over A. Okay, so put all the values and you can find the value of mass. Also you can work on this one. Again, you can also work on this one. So Newton laws proves that different masses accelerate. This is very important thing to understand the Newton law of Newton's second law. That also proves that different masses accelerate to the earth at the same rate but with different forces. How? So we know that objects with different masses, here we can see the mass of an object is 10 kilogram, and here also we can see a little mass is equal to 1 kilogram. So the force of gravitation is also acting on this object, is this one and also this one. The force will be different. Again, this force will be different. So from here we can find out the forces. The force of gravitation is 98 Newton, and for this the force of gravitation is 9.8. So let's solve one by one. So here is A is equal to F divided by M. So put the value of F. What is the value of F? 98 Newton is the force. Also the mass is mass of this object is 9.8, or we can say 10. So acceleration of this one is 98 divided by 10 kilograms. So this will be equal to 9.8 meter per second square. Again, for this mass, acceleration is equal to force divided by mass. So acceleration is equal to 9.8. The force, applied force, is 9.8 Newton over the mass of this object is 1 kilogram. So the acceleration will be same. You people can see that this mass is larger as compared to this mass, 10 times larger. So 9 times larger than this mass. So the acceleration is same. So it means that Earth is attracting any body, no matter it is large, no matter it is small. Both bodies are coming to the earth with the same acceleration. So we know that objects with different masses accelerate to the ground at the same rate. However, because of the second law, we know that they don't hit the ground with the same force. Okay, the force will be different, but the acceleration will be same. So this was the start of classical physics. This is very famous story when Newton was seated under a tree, under the apple tree. So an apple was fallen to the head of Newton, and Newton think, why it comes to me? Why do not come up and to the right of me, to the left of me? Why it only comes to me? Why? So then he thought, and he gives the three laws of motion, also the law of gravitation, and this is the expression of uh, law of gravitation. Fg is equal to g m1 m2 divided by r sec. This is another topic. So again, now you can check your understanding what acceleration will result when a 12 Newton net force applied to a 3 kilogram object. So 6 kg object. Okay. So also on both you people can check your understanding as well. So on the other questions are as well. Also, I have solved some questions here, and now the examples are force. So force is basically is the push or pull that causes a change in the motion of an object. As we can see, this moon is moving around the earth, and this earth is moving around the sun, and only sun is carrying all of the planets to the another galaxy. And here you also can see the force between objects, that is gravity. Also electricity, you can see state electricity, also the magnetism, also the friction force also. So now let's move towards the third law of motion. So very fastly, so for every action there is an equal and opposite reaction. So I have placed many pictures. For an example, a rocket is driven by Newton's third law of motion. Action triggers and reaction. Action triggers reaction. Okay, this is the reactionary force, which is applying by the action force of the rocket fuel, and the rocket is moving. Also, if you fire a bullet from pistol, from any kind of gun, so you will feel the bullet will, when the bullet will release from the gun nozzle, you will feel the gun is moving back. Also here you can see, also this person is moving towards here. Also as in our childhood we see some action, here rushes down and reaction balloons go up. Why? Because the air is rushes down. Okay, so next one is, according to Newton, whenever object A and B interact with each other, the exert force upon each other. When you sit in your chair, your body exerts a downward force on the chair, and the chair exerts an upward force on your body. So that's why you are stably and successfully sit. You can sit on the chair as well. So that here you can also see there are two forces resulting from this interaction: a force on the chair and a force on your body. These two forces are called action and reaction forces. In Newton's third law in nature, you can see the fishes are moving, and by their feathers they are applying the force on water, and water is pushing the fishes to the front direction as well. So here also an example of Newton's third law of motion: flying gracefully through the air. Birds depends on Newton's third law of motion. As the birds push down on the air with their wings, the air pushes their wings up and gives them lift as well. So also consider the flying motion of birds. A bird flies by use of its wings. So the wings of a bird push air downwards. So in turn, the air reacts by pushing the bird upwards. So the size of the force on the air equals the size of the force on the bird. So the direction of the force on the air downwards is opposite the direction of the force on the bird upwards. So action reaction force pairs makes it possible for birds to fly. So this is also an example. So other examples of Newton's third law of motion: the baseball force to the bat to the left. In action and reaction, the bat forces the ball to the right. This is the reaction force. So this is the, consider the motion of a car on the way to school. A car is equipped with wheels which spin backwards. As the wheels spin backwards, they grip the road and push the road backwards. So also this rocket, as I already given you these examples. Thank you very much.